Hello dear student, my name is Vikas Kumar. Today I am going to teach structure of atom for JEE Mains and Advanced. Now question number 1 is the atomic nucleus contains proton, neutron, electrons and photons. In given options, actually in atom electrons, protons and neutrons are present. Electron is negatively charged particle having single negative charge, proton single positive and neutron no any charge. Now mass of electron, relative mass 1 by 1837 gram. Okay. Now relative mass of proton is approx 1 gram and neutron is also 1 gram. So here in nucleus, inside nucleus of atom, mass particles are present, total mass particles are present. So mass particles are only proton and neutron. So all protons and neutrons situated inside the center of atom or nucleus of atom. So the atomic nucleus contains proton and neutron. So option A and B is correct. You can take a screenshot. Now question number 2 is based on isoneutronic. According to question number 2, an isotone. Isotone means isoneutronic. The answer is, options are given. So isotone means same number of neutrons, or they are also known as isoneutronic species, but different number of protons or atomic number. Okay, now we can easily find, you can take a screenshot one by one. Here electron is 32, proton is also 32 and neutron is 76 minus 32, so 44 neutron is here. In first case electron is 32, proton is 32 and neutron is 77 minus 32, so 55 neutron is here. Now here neutron is 45, here neutron is 44, so option A is wrong. In case of option B, electron is 33, proton is 33 and neutron is 77 minus 33, okay, is equal to 44. So atomic number is 33 and 32, different number of proton is different, but number of neutron is same, 44 and 44. So option B is correct. Now option C, electron 34, proton also 34 and neutron is 77 minus 34, so 43 neutron is present here. So neutron mismatch, due to mismatch of neutron, option D is also, option C is also wrong. Now option D, electron 34, proton 34 and neutron is 78 minus 34. Now 44 neutron is here. So 44 neutron match with germanium and number of proton 32 and 34. So option D is also correct. You can take a screenshot. Now I am going to solve question number 3. According to question number 3, the radius of an atomic nucleus is of the order of, these options are given. Now in case of atom, we can observe this is nucleus of atom, and for hydrogen atom first shell is here. So this is radius of atom. Now 10 to the power minus 8 and 10 to the power minus 8 centimeter and 10 to the power minus 13 centimeter. These two values are indicates respectively radius. Now radius of nucleus, according to question, radius of an atomic nucleus, nucleus means nucleus. So radius of nucleus is very less than radius of atom. So this is radius of nucleus. Okay, this is radius of atom. So option B is correct. You can take a screenshot. Now question number 4 is based on alpha scattering experiment. According to question number 4, Rutherford's scattering experiment is related to the size of the nucleus, atom, electron and neutron. Okay. Now, in Rutherford alpha scattering experiment, Rutherford took a thin gold foil, and whenever beam of alpha particles strike at thin gold foil, then you can observe whenever alpha particle strike at thin gold foil, thin gold foil, thin gold foil, then you can observe this type of figure in your books. And now alpha particle is just like helium, having 2 positive charge and mass equal to 2 mu or 2 hydrogen atoms. So alpha is carry 2 positive charge, alpha double positive, 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 double positive and double positive. So whenever alpha particles strike at thin gold foil, then most of the alpha particles, 99%, strike at gold foil and across gold foil without deviation. Some alpha particles are slightly deviated from their path, 1% or less than 1% near about, but very few number of alpha particles, 1 alpha in 20,000 alpha particles return back from their path. So after experiment, observation is most of the part inside atom is vacant, and due to 1 alpha particles return back from their path, 1 means 20,000 alpha particle, 1 alpha in 20,000 alpha particles. So total mass particles means total number of protons and neutrons present at the central part of atom, which is called nucleus. Now, according to question, Rutherford's alpha scattering experiment is related to size of the nucleus, atom, electron and neutron. So after alpha scattering experiment by Rutherford, nucleus is discovered. Okay, so you can take a screenshot. Option A is correct. Now I am going to solve question number 5. Question number 5. The outermost electronic configuration of the most electronegative elements according to given options in case of non-metals. Valence electron 4, 5, 6, 7. Top to bottom increase electronegativity of metals. But whenever valence electron is 8, then non-metals are non-reactive. Okay. Now, according to given options, in NH2, NP3 valence electron is 3 plus 2, 5. NH2, NP4, 4 plus 2, 6. NH2, NP5, 5 plus 2, 7. NH2, NP6, 6 plus 2, 8. So this is non-reactive last cell configuration, and top to bottom electronegativity become increased. So due to presence of 7 electrons, option C is correct. You can take a screenshot. Now I am going to solve question number 6. According to question number 6, correct set of quantum number for the valence or outermost electron of rubidium. Here atomic number Z is equal to 37 is. These options are given. Now rubidium 37 atomic number electronic configuration is 1s2, 2s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6 and 5s1. After arrangement, again we can write electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6 and 5s1. Now this is first cell, second cell, fourth, third cell, first, second, third, fourth and fifth. Okay. Now in fifth cell for 5s1, 5s1. Here 5s1 means n(s1), n is equal to 5. Now n is equal to 1 to infinite. n is principal quantum number, L is azimuthal quantum number or secondary quantum number. Value of L is 0 to n minus 1. L is equal to 0 for S, L is equal to 1 for P, L is equal to 2 for B, L is equal to 3 for F. Now M is value of M is magnetic quantum number. Value of M is minus L to 0 to plus L. Okay, M is equal to 2L plus 1. Okay, now S is plus minus half for clockwise spin of electron on their axis and minus half for anti-clockwise spin of electron on their axis. Now we can find set of quantum number, 4 set of quantum number. Now n is equal to 5, L is equal to for S0, M is equal to 2L plus 1. So 2 into value of L is 0 for S, 0 plus 1 is equal to 0 plus 1 is equal to 1. So now value of M is 0. So M is 0, and for S spin quantum number or clockwise spin plus half. Value of S is plus half. So 500 plus half is correct answer. 500 plus half, option A is correct. So you can take a screenshot. Now question number 7 is based on calculation of angular nodes and radial nodes. According to question number 7, the number of radial node in 3s and 2p respectively are, options are given. Now from formula, number of radial nodes is equal to n minus L minus 1, and for number of angular nodes is equal to L. Now with the help of this formula we can solve this question. Now number of radial nodes in 3s, okay, n minus L minus 1, n is 3 minus L is equal to 0 for S. So L is equal to 1 for P, L is equal to 2 for D, and L is equal to 3 for F. Now 3 minus 0 minus 1, 3 minus 1 is equal to 2. So 2 is 2. Total number of angular node in 3s is 2. Now in case of 2p, number of radial nodes in 2p, n minus L minus 1, n is 2 minus, now L is also 1 minus 1, 2 minus 2 is equal to 0. So 0. Now answer is total number of radial nodes for 3s and 2p respectively is 2 and 0 respectively. So according to given option, option A is correct, 2 and 0. You can take a screenshot. Now I am going to solve question number 8. According to question number 8, the correct ground state electronic configuration of chromium atom is, options are given. Now atomic number of chromium is 24, electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s, 2 and 3d, 4. Now 1s2, 2s2, 2p6, 3s2, 3p6. This is the electronic configuration of inert gas element argon. So we can write here argon, atomic number 18. After that 4s2 and 3d4. Okay. Now we can also write 3d4 and 4s2. Now we can observe last cell is completely stable because S is stable whenever they are completely half filled or completely full filled. In case of P is also stable in case of completely half filled or full filled or full filled. Now D is also stable whenever they are completely, their orbitals are completely half filled or completely full filled. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now in case of F is also stable in F7 configuration and F14 configuration. So last cell is stable due to presence of paired electron in S2 or S2. But here 3D4 is unstable due to absence of single, due to absence of one unpaired electron. Okay. Now situation is this. Now one electron shifted from 4s2 to this orbital. Now we can observe a stable configuration. So after shifting of electron, 3d4 transform into 3d5 and 4s2 transform into 4s1. So this is correct electronic configuration of chromium 24. Now you can select correct answer in these options, and option A, argon 3d5 4s1, 3d5 4s1. So you can take a screenshot. Question number 9 is completely based on quantum number. So I am going to solve this question. According to question number 9, the principal quantum number of an atom is related to the size of orbital, spin angular momentum, orientation of the orbital in shape, and orbital angular momentum. Actually, quantum number first is principal. Principal quantum number denoted by n may represent about all information of orbit inside the atom. Now second is azimuthal quantum number. L represent sub orbits inside the atom. Third is magnetic quantum number denoted by M and represent number of orbitals inside the atom. Fourth is spin quantum number denoted by S. So spin quantum number represents spin of electrons on their axis. So S is plus half, so spin is clockwise. S is minus half, so spin is anti-clockwise. Now according to these informations, whenever value of n 1, 2, 3, 4 to infinite, with increase in value of n, size of orbital become increased due to increasement of size in atom, because orbital distance from center and last cell distance is become increase. So option A is correct. Now question number 10 is based on number of nodal planes. Now according to question, the number of nodal planes in px orbital, options are given 1, 2, 3 and 0. So the number of nodal planes in px, okay, in p suborbit, orbital is px, py and pz, orbitals are pertinent. Okay, now one by one we can draw shape of p is dumbbell shaped. In case of px, here x, y, z, x dash, y, z, z dash. Okay. Now in case of this is Px orbital. Now Py is x, x dash, y, y dash, z, z dash. So this is Py orbital. And now in case of Pz, x, x dash, y, y dash, z, z dash. So Pz orbital is here. Now according to question, the number of total nodal planes in Px, only for Px, nodal plane is 1. Here nodal plane NP is also 1. Here nodal plane NP is also 1. So total nodal plane in P, NP is equal to 3. Total nodal plane in this place for P suborbit, total nodal plane 1 plus 1 plus 1 3. But in case of Px, only one nodal plane. So option 1 is correct. You can take the screenshot now.